The first part of this packet is kind of a combo packet. The first part's going to be kind of getting us some examples, and this might even come in handy when we get to a quiz, because you're actually going to get to use a homework assignment on a quiz, which I never do. But this first part we're going to do to kind of get you working on, and then whatever we don't finish together, this first part, we're going to go ahead, and that's going to be the first assignment in our next homework check, is basically what we're going to be up against. So up at the top, it explains a little bit about what this thing called a function is. And basically, they talk about this thing called input and output. Well, let me explain what input and output works a little bit here. Wish I wouldn't have written homework check 11 right above it, but that's okay. Input's just a fancy way of saying it's my x's. Interesting marker. And output's just a fancy way of saying my y values. So there's always going to be one x and one y that goes together. And if that's not true, it's not what we call a function. And this is kind of my easier way of looking at it. My x values have to be different. So, and then it says a function must pass the vertical line test, even though my L got cut off here. Which direction's vertical? Up and down or left and right? So it's one of them. Okay, it's an up and down one. So let's make a little note in here with my line to get myself situated. So when we're looking at these, one thing I have to be able to keep track of is when I see values, what values are which. So whenever I'm looking at an ordered pair, the x values are always going to be my first value there. And my y's are always going to be the second one. And that's important because when we go to try to figure out a function, if we're not looking at the right parts, it really doesn't help us out that much. So what we're going to do is we're going to look at these ordered pairs on a graph. We're going to look at them in what's called a mapping chart, and then we're going to look at them like a regular chart that we'd normally do. So here, when I'm trying to graph a point, if I wanted to get to the point 2, 1, what directions would I need to go? Okay, which one's the up? The 2 or the 1?
2.
Close. The 1. Okay, the 1's my up. So x is always going to be my part that goes left and right. Y is always going to be my part that goes up and down. So here, I'd go right 2, and I'd go up 1, and that would be my first point. But that first point's always left and right. So here, positive 3, positive, we go to, well, where the x is 3, to the right. And then negative 2 for y, I notice, goes down. So I'm not doing a separate point for each one. I just do them together. If x is negative 3, I go left, there's the negative 3. And 1 is positive, so I go up 1. And then finally, if my x is a positive 2, my y is a negative 2, I would just get my dots. So these two things could actually be represented the same way. If they give me the points, okay. If they give me it this way, that's okay too. And we'll talk a little bit about the graph part here a little bit more in a minute. Now you're like, why are we going to x and y? Why are there these big egg-looking things here? Sometimes there's this thing called mapping. And here's how mapping works. You write down your x values in here, and only the ones that are different. So like for instance, I notice x is showing up twice. I don't write it twice in here. I just write it once. Some people might even be picking up and say I really should be putting the negative 3 at the start so they're in order. I'm not quite as worried about that. And then my y values, same thing. As long as they're different. Say the 1's the same again. Oh, and so is the negative 2. So I've only got 2 numbers to draw in, but here's how mapping works. You take whatever your x value is in the y, and you're just going to basically connect them. You're playing like connect the dots, sort of. And sometimes you may have a number going to a number more than once. So like if x is 3, okay, y is negative 2, it got this. If x is negative 3, y is 1. So again, they can go to the same number. And if x is 2, y is negative 2. And like I said, at first we just want to get everything drawn in and kind of see how it works. And then finally, a chart we might be a little more familiar with, just our regular t-chart. Now this one we do write everything, whether it's there twice or not. So x is 2, y is 1. And the only reason that we're doing this right now, if some of you are kind of wondering, is that we're going to see problems in all of these different forms, and we've got to be able to find the information that we need from them. So when I'm going to do this, the first question I got to ask myself is this a function? Well, let's see. If we're looking at a function, and we can even look at it from the ordered pairs, it says the x values must be different. Are all of my x values different in my coordinate points? Are these all different? No. Okay. First of all, my x's aren't all different. So that's one thing I notice. Here's another thing I notice. It said if we're looking at a graph, for it to be a function, it must pass the vertical line test. So what that means is I'd have to go through, and anywhere in this entire graph, I'd have to be able to draw a vertical line, and it would only go through the graph once. So I'm like, through one point at a time. So as I kind of start to move my vertical line through here, I get to a point and I go, oh, if I were to actually draw a vertical line at this point through my points, I'd look and I'd say, well, it passes through 2 points. And it only has to be in one place, so that doesn't work either. So it also doesn't pass the vertical line test, because to pass it, it can only pass through 1 point at a time. And that's kind of what we're looking at. So it might be noticing my x's are the same, because here I have two x values of 2. It might be in a chart like this. Now this one's a little trickier to see. I'm going to try to highlight it here. If my x values have to be different, I have two x's. I have one x value that has 2 different y's. Okay, one x value, in this case that would be 2, cannot have 2 y values. In other words, I can't have x equals 2 and have y equal 1 and y equal 3. That doesn't make any sense. Because, well, if I plug in one number, I got to get one number out. And I also see again over here, my reason that it's not, again, a function is the same thing. I can't have those repeater x values. It just doesn't work. Splash you. So the only other thing we've got here, and then we'll get into some of the simpler ways of looking at it, is this thing called domain and range. And that kind of goes along the same idea. Domain is just a fancy way of saying all of my x values. So when I'm asked for a domain, I use this funky kind of thing called a brace. If you really look at it, it looks like a guy with a really out there chin and forehead and a pointy nose. I used to compare him to Jay Leno, but then nobody knew who he was anymore. So what I'm just going to do here is I'm going to list my x values. So I've got, let's see, 2 and 3 and negative 3. And if there's a repeater, again, I don't need the repeater. So you're like, oh, it's just sort of like listing them sort of like we did with the mapping thing. And it is. And then my range is just going to be my y values. And again, I only can list the ones that are unique, that are different. So if I start listing, I'm like, okay, 1, negative 2, oh wait, 1 repeats, oh wait, negative 2 repeats. Okay, I only got to put those 2. But that's, if you're ever asked for domain and range, that's what we're looking for. What are my x values? What are my y values? I can figure those out. And again, that just kind of talks about some different ways we can see these, and it's kind of nice to have these available. So are the following graph functions, do they pass the vertical line test. Well, let's see. If I start going through, and again, remember, I'm just looking to see, is there a place where my graph passes through more than one point? So like if I were to draw a line here, and again, it can be anywhere. Now it's just here. Or if I do it over here, it's just there. If I do it here, it's just there. This one looks good. So this one looks like it's only going to pass through one point. So this would be yes. But again, that's not always going to happen. Oops. Sometimes, as I'm going along, I'll go, oh, if I were to draw a vertical line through here, it goes through at this point, and it also goes through at this point. And any number of points that it goes through that's greater than 1 makes that a no. And so basically, whenever there's a graph and we're being asked for that, we're basically just going to, and even if it's just points, I'm running a vertical line test through just to see, is there any place where if I have a vertical line, it's going through more than one place at a time? And if it's not, it's yes. But if I try that little game, and it can just be even the side of your piece of paper that you use. But if I get to a point and it's like, oh, there's a spot where there's 2, that's always a bad sign for us with a function. But that's all there really is to it. So it's not like it's a crazily hard thing to do. As you can see, we didn't have to do any equation solving or anything. We're just looking. And it's the same thing as we go all the way down these. Are the following ordered pairs functions? Are all my x values different? Yeah. As long as they are, it's yes. If I look at my x's, nope, doesn't even come into play on these. If the x's are all different, we're good. But that's a good question. Because sometimes people will say, and they'll go, oh, I have the y is the same. It's 4 and 4. It's no. It's only about the x values. If the x values are different, we're good. If I get a repeater x value, like I do in number 6, then it's no. And that's it. So again, the one nice thing about functions is it's kind of straightforward. Same thing here. Are my x values different? And as soon as I see one that pairs up, it's no. But as long as they're all different, that would be a yes. So you're like, okay, this stuff's not terribly awful, especially since there's not a lot of work to show. Some of them pop back up. All right, let's check this out. Are the following mappings functions? In other words, are 2 arrows coming out of one x value? Because that's when we're going to get multiple x's if we were looking at the values. As long as there's only one arrow coming from each x value, and again, domain's just a fancy word for x, then we're good. Then we have a function. But when I see that x value, and I see 2 arrows coming out of there, if I were to look at these as coordinate values, this would be like having 2, 4, and 2, 6. Well, there's the same x value showing up more than once. So that one's going to be a big old no. And we're good there. And basically the only thing that we've got left then is something that's called function notation. Now you look at this and you're like, f of x, g x, what's all this stuff? Do I have to solve for those, or how does this work? F of x and g of x are just fancy names for y. And the reason I use different letters on them is that way I can tell which one I'm plugging it into. So like here, when this says f of this, I'm just going to plug the -2 in where the x goes in the function that starts with f. So for instance here, I'd have 3x, but this is my x value, minus 8. So the letter in front just tells me which one I'm plugging it into. So 3 times -2 is 6, minus 8 is -14. Exactly. So whatever's in the parentheses, okay, whatever's in the parentheses goes in for x, even if it's another variable. Because, yeah, you look at 12 and you're like, wait a minute, I'm plugging a variable in for the variable. Yes. G is the function I'm plugging into, so I'm plugging into here. So any place I see an x, I am going to plug an n. So you're like, all I really did is just swap the variable out in that one. Yes. And sometimes that's going to need to be necessary. We'll work with things that have multiple variables, and then we'll just do that, and it's okay. So let's see here. Here's another f, so it's going to go in this one. So instead of writing 3x, where the x goes, I just plug in what's in the parentheses. It's basically, we're just doing substitution, but instead of always doing it with just a number, sometimes we're doing it with a variable, and then we can distribute. Because again, whenever we see parentheses, we know we're multiplying or distributing anyway. 3 times 2 is 6. Is that one simplified as much as it can be? Is there anything else I could do? Do I have any like terms? Yeah, I've got those like terms. Now be careful. These are on the same side. It's not like they're on opposite sides. I don't have to like -6 or +8. I just put those together. So what's 6 and -8 going to get me? -2. Okay, so that's what we want to get to. Whatever it simplifies out to, that's what we're trying to do. And that's going to be the same on any of these. So like here, f says plug in 4t where x is at. Okay. Plug in 4t where x is at. 3 times 4 would be 12t minus 8. And unlike the last one, this has t, this doesn't. I can't do anything else. That's as far as I can go. Thank you. Now, am I always going to have something, you know, that's just in the parentheses? Nope. Like here, it says g of m. Okay, so I'm going to plug in m where the x goes. So m squared plus 6. But then there's a +2 on the end of that. Okay. I find the things that are alike, the plain old numbers. And then I just copy whatever else is there. And I'm good. But they can change up the things that we do sometimes. Ooh, I even get to do both of them this time. Okay. So f of 4. All right, let's see here. Here's my f function. So f of 4 means I'm going to plug in 4 where the x goes. Minus 8. Okay, so that takes care of the first one. That says plus g of -4. Okay, so I'm going to plug in -4 where x is at. Notice I keep using parentheses because I want to make sure my answer comes out right. And there is no shame, ever, never, never, ever, if you get one of these and you say, you know what, I'm just going to type this whole thing into the calculator and let it spit it out at me. Because as long as you've set it up right, you're going to get the right answer. And the bigger thing in here is, you know, can I set it up? Oh, not 9, though. About 6. Okay. So you don't have to do everything by hand. Get it set up. Just pop it in there. F of -t, okay. So I'm going to plug a negative t in where x goes. Now I can't leave this one quite. There's a little something I can do. Positive times a negative just makes it a negative. And we're good. And all we're doing, use the letter in front to tell me which one I'm plugging into. And then wherever that x value happens to be, that's where I'm plugging what's in the parentheses. And again, whenever there's parentheses, I know I have to distribute. I know that I'm multiplying. So, what's that? No, I don't think it's a negative 9. Yeah, negative 11. So all we're going to do, as we're doing these, is we're going to go ahead all right, so this last one's kind of throwing one more twist at us. You're like, wait a minute, 4FD. Now, how's this work? Here's how this is going to go. I'm going to do my substituting first, so I'm going to ignore that 4 for a second. So I'm going to take my f function, I'm going to plug in the d, where the x goes, like I'm supposed to. And once I do that, and simplify it, now I'm going to go back, and that 4 in front just means I'm going to times through here by 4. So just do it a piece at a time. Don't try to do it all at once. 4 times 3 is 12d. 4 times negative 8 is negative 32, and I've got it. Okay? Just don't rush. Okay. So now, a couple of quick little reminders, and I'll have you off and running here. On number 4 here down below, put an X through that right now. We have not touched on that quite yet. I got a little ahead of myself when I put this part together. But the other ones, again, on the tables, just use what you've got on the front to determine if it's a function or not. Nothing else fancy. And as you're working through into the next part, okay, here's your F's and G's. Here's your functions. You're just plugging those in for X like we did before. Again, use your examples to figure out if these are functions or not, using whatever test you're supposed to. A little more practice substituting down here. And I think we just got some other things I'm looking to see it's a function, and we're going to be done. Actually, I do see one, though. Actually, I see a couple. Let me come back here to the back for a minute. I want to take a look at a couple of these on the back page up at the top. Oh, excuse me. I moved out of the way a little bit there. All right. 48 up here at the top. It says Christina earned $7.50 an hour babysitting. Write an algebraic expression to represent the money Christina will earn if she works H hours. Well, now, whenever you're working a job, it's whatever your pay is per hour times the number of hours you work, and that's how we figure out how much you make. So all I'm doing here basically is saying, okay, how much do I make an hour? Well, I make $7.50. How many hours do I work? H. I'm not going to be able to tell you right now how much she made. I don't know how long she babysat. But this just allows me some flexibility. If she works 10 hours, I can figure it out. If she works an hour, I can figure it out. Whatever it happens to be. So don't see a story problem like that and just skip it. Put it into something that makes sense. You know, I'll know how this works. You make money for an hour, for some hours, multiply by the number of hours, you're good. And then the last one, we're going to do some more like this as we go along too, to try and figure out what the reasoning is behind this. So we're looking at this relation, trying to figure out if it's a function or not. Is either of them correct? Let's forget what they say for a minute. I don't care what they say. Let's figure this out ourselves. is this one a function or not? Are all my x values different? Do I have any double arrows coming from any of my x's? No. So this is definitely going to be a function. So now that I know what the answer is, now let's see what they think. Horizon, no. Wrong, because it's yes, we know this. Oh, no, what? Now, Maggie has the reasoning right. Each one of these matches with one value over here. That's right. But Maggie needed that to say yes, and she'd have been good. So that's some of the thought processing we're going to work on doing. And we're good to go. Okay? So your job is just to knock out the rest of these. Again, use the front of the notes if you need to get you some examples of what the different parts would look like. But you got plenty of time to get this knocked out, and that should set us up for now.